All right, welcome back, everybody. I'm really pleased to introduce June Zakrajsek. June is the head of the Radioisotope Power System Office, and as you all know from the engineering part of the week, the plutonium-powered units that her office provides to missions like Mars 2020 and New Horizons, Cassini, and more is fundamental to the operation and success of a mission like this. It's really great to have her here telling us basically where the program is and what we have to look forward to. And with that, June, you want to go ahead and take it away?
Sure. Can you hear me okay?
Yes. Thank you very much for
Okay,
being
great.
here, June.
Yeah, no, thanks for inviting me. I know I presented to this group before, maybe over a year ago. And so thought it was about the right time and Michael thought it was as well, to come back and at least give you a status on where the program is. Especially, I wanted to talk a little bit about what we're doing with NextGen RTG. I think that might be interesting to this group particularly. Let's see if I can actually get the slides to change. There you go. So as Michael said, and as I think you probably are mostly all aware of, RPS provides power that allows the missions to explore, discover, and understand. And one thing that's really important to the program and to me is understanding that we're here to support the missions, right? We're not here because we want to put a new power system out there. NASA, the agency, doesn't have a goal or an objective to put a new power system there. It's really about that exploration, discovery, and understand. And everything that we're trying to do now in the program is really focused on making sure that we put the missions first and we think about how we're doing things in order to support the mission. And so we've done a lot of reorganization. And one thing that when I think about the program and I think about how we approach it, there's like 4 P's that we have. The first is the people. And I don't know about you guys, but with COVID, really focusing on our people is even more come to light as being important. And we really have a lot of diversity and support from a lot of great people in the RPS program. We've moved to a leadership structure that is not just one organization centered. And I feel that's really important because we allow a lot of different input in from the different organizations. So we have people on the leadership team, not only from NASA and at Glenn, but also from JPL, as well as from APL, as well as from the Department of Energy. And we're all focused on trying to make sure we get the power out there to support the missions. I just didn't know if someone had a question.
I'm there.
Okay. And so, and we do that to provide the power. And one of the important things in providing that power is making sure that we can fuel those systems. And so I'm pretty sure I've said this before, but in the production area, we need plutonium-238. We have some on the shelf that we can use, but we need new plutonium-238. And over the last decade, a lot of people worked really hard to make sure that we could secure funding to do the reestablishment of that within this country that we lost over about 30 years ago. And we have successfully done that, we being pretty much the Department of Energy. The Department of Energy has been able to reestablish capability. And we've actually shown that end-to-end a capability at DOE, because some of the fuel that is on Perseverance, that's on its way to Mars, it contains some of the new fuel that was produced. And so right now what DOE is doing is it's scaling up. And they scale up looking at a 10-year window, basically, based on what NASA feels and what planetary feels it needs to fuel. And so we have, that included in this decade, Mars 2020, It includes considering Trident, which would need 2 MMRTG systems. It includes Dragonfly. It includes a mission that would use a NextGen system for 2030. And it includes a couple GPHS modules, which is the heat source modules that might be able to be used for a demonstration on the lunar surface for dynamic. And so we've set that such that by 2026, DOE would increase the production to about 1.5 kilograms on average per year of new PU-238. And taking the power and the production together, it allows us to fuel the systems that allow the missions to make progress. But we also in the program are looking at making progress to make sure that the systems more effectively help the mission. And that generally is looking at increasing the efficiency of the systems or providing systems that might have a different power. And as you know, this is just a fleet chart, and you can see that we have successfully used systems over the past 50 years. And they've gone everywhere, even outside of our solar system. And so we want to make sure we keep those kinds of systems available to the missions. The technologies that we have currently for RPS is the multi-mission radioisotope power system. It's the MMRTG. It, as I said, is on Perseverance. It is also on Curiosity, and it will be used either for sure on Dragonfly, and it will be potentially used on the mission being planned on Trident. So that is a system. It's about 110 watts, but and we have that, and it allows us to go to places that have environments as well as deep space. But we were looking to get back the capability to get to deep space. So we have a NextGen RTG project. And I'm going to talk a little bit more about that on the next few slides. So I'm not going to talk that much about that here. But we also have investments in the dynamic area. It would also be a multi-mission system. And it would be dynamic based. And so with that, we really are focused on trying to look at robustness and reliability, because we know no one really wants to hang their hat on a system, a dynamic system that is unproven, which is why I talked about trying to do a lunar demo of that system. And why is dynamic important to us? The floor of it could be about 4 times more efficient. And so that's important to us, because that allows us to be good stewards of the fuel that we have. But let's talk a little bit about NextGen RTG. So NextGen RTG was to get back a deep space kind of system, a larger system, something on the order that of the GPHS RTG. And that's the system that is powering New Horizons. That's the system that was used on Cassini. The heart of that system, if you want to call it, the thermal electrics of that system, are on Voyagers and on a number of the other missions I can show you in a slide or two. And so we went out over a year ago, working through the Department of Energy with a procurement process to get to that kind of a system. And we're looking for a higher efficient system. And we offered to the 2 contractors any kind of technologies that the government had, as well as they could bring any technologies to the table. And we had Lockheed Martin and Aerojet Rocketdyne. And both of the contractors, after the phase 1 design effort, basically said, if you are interested in flying a mission in 2030, and you're trying to get to a qualified system by 2028, we feel that the best conversion technology that you have out there is the silicon germanium technology. Again, that's the system, that's the technology, that's the material that is used in the GPHS RTG, a picture of which you see in the upper right-hand corner. And the unicouple itself, that heritage unicouple you see in the bottom. you can do the other. You can on-ramp new technology, but if you do that, it's high risk. There's an additional cost threat. Okay, and so both contractors proposed the silicon germanium conversion technology, as well as a path forward to on-ramping a higher performing thermal electrics in the future. And so when we sat back about that and we looked at how the contractors had proposed their work, they were both designing very new systems. Okay, and in that, you go through that whole design process, right? You go through the whole PDR, CDR kind of process. And so it was costing a lot more money. And in the end, we were only getting about a 10% gain in power. And so we took a step back and we considered that we have a design, right? We have a design, a GPHS RTG design that has served us well. It probably is the best for us if we go back and we try to reestablish the capability. If we do that, we could bring down the funding, lower the risk, and hopefully serve the missions faster and better. So with that, and knowing, okay, so knowing that the heart of that system has a long pedigree, I'll call it, of heritage for reliability, right? You can, LES 8 and 9. 9 just got decommissioned this year, right? After 44, I think it is, years of service. That's a long time, right? Voyager 1 and 2 is over 40 years, 43, I think it is, right? New Horizons and Cassini, right? Some of those missions are like yours and are, past our solar system. So that type of heritage is also something that we felt is a good reason to go forward and go back to reestablishing the capability to produce a GPHS RTG. And I think I should tell you, when we started on the NextGen project itself, we were going for that higher performance system, but we did have this base requirement that said, we want this is your goal for this higher performance, but give us nothing less than a GPHS RTG. So from the very beginning, we had that thought process, or headquarters had that thought process for us. And so we are still committed to bringing back that deep space capability. This approach we feel is more cost effective and has less risk and can deliver a system earlier than 2028. We can also deliver 2 unfueled flight systems, qualified systems, to a shelf that a mission can use. And let me explain the first of those systems, because I haven't really talked about it yet. We have, the Department of Energy has, on behalf of the government and NASA, a GPHS RTG. They have hardware as well as multi-100-watt hardware. And they have a GPHS RTG qual unit that they have. And for a small investment, we can refurbish that qual unit that could be used for a mission for flight. And even if we don't use it for a mission for flight, it is a great pathfinder. These systems were developed so long ago that most of the folks that developed them are no longer working. And so the new group of engineers, it would be great for them to get their hands dirty, I guess I'll call it, by refurbishing that and getting a lot of understanding and knowledge that can be beneficial to what we call Mod 1. So since NextGen, the idea of getting to that higher performance system is not going away, we're still keeping that same title, all right? Mod 0 basically is a GPHS RTG. The Mod 1 is a very close GPHS RTG design. And I say it that way because we know that we're going to have some changes. Just the fact that the modules that fuel the system will be different for a Mod 1 system, then the original GPHS RTG makes that going to be a little different. But the approach of doing that allows us to get these 2 flight qualified systems on the shelf by 2026, which leaves us even more margin to fuel mission for 2030. Now, both of these systems would have anywhere between 177 to 210 end of design life, think 17 years as your life, power. And it's written that way because for Mod 0, we are considering flying a step 1 module, GPHS module, and to fuel the systems. And if that's the case, we would get the 210. If we end up for Mod 1 using this step 2 would give us around 177. Basically, we can't fit as many modules in the generator, therefore less heat in, less power out. That's basically what you're seeing there. But more importantly, we will have the ability to make more because we'll have reestablished that production line. So we think that that's a really good thing for the community. And why we do that, there will be a group of folks working on increasing the technology readiness level of the higher performing thermoelectrics that if it was a perfect world would be able to be ready at the same time that the first system rolls off, the Mod 1 rolls off the new production line. So then we could work on integrating that new thermoelectric technology into the design. So we try to look at how best to do this, balancing cost, balancing schedule, balancing risk. And so that's where we have gotten to this new path. Again, this chart just gives you a little bit better anchorage into the approach. You know, Mod 0 is the refurbishment. Mod 1 is really a 90% heritage design. Is close to one of the things we are considering, but we will balance cost and risk in doing it is if you cut the generator in half. So maybe being able to provide a smaller system because we think that might be beneficial to missions. And that modularity was part of the original NextGen. In Mod 2, we'll try to get to that end of design life goal that we had originally of 290 watts, as well as the modularity. But again, that's post 2026. And so this is just another way of looking at the same information, but we really are committed to making sure we can have at least one system per mission in 2030. We feel that the way that we've done that, we'll be able to have one early in 2022. It'll be basically a GPHS RTG. We'll be able to provide a Mod 1 NextGen, which will be very much like a GPHS RTG by 2026, at the same time as reestablishing that production line. And we will be able to do that for about 80% of the original time that we estimated and about half the cost and less risk. So this should, and at the same time, developing that new thermoelectric technology that would increase the performance in the future. So again, we're doing that. We feel that there's a lot of good things that are going on in the program besides NextGen with our missions. And with Perseverance soon to land, with the potential Trident mission, and also with the Dragonfly mission coming up. And we really look to our heritage and some of these older missions that we have, or the missions that are still currently active, and trying to make sure that we are looking at all options to serve the mission community. So I guess that is what I have. So if you have any questions, I'll be glad to answer them.
Yeah, thank you very much, June. We have time for a question or maybe two. I know that time on. So any questions for June? Thank you very much. It was fantastic. I see Alan's raised his hand. You want to go ahead, Alan?
Yeah. Can you hear me, Michael?
Yep.
Yeah, June, thank you for that presentation. I'm a little unclear about the path forward. It sounded like NASA needs to make a decision, that there's some branch or a couple of different choices that they need to choose between in order to get on a deterministic path to this new system. Can you summarize if I'm correct or incorrect, and secondly, when those decisions will be made?
So NASA, I think, has decided. The decision is to reestablish the production line of a GPHS RTG with the intent to later infuse new technology that would improve that. We have 2 contractors right now. Maybe this is what you were thinking of. We are in the process of down selecting to 1 to carry out the reestablishment of the production, as well as providing these systems. So that's the path that we're on for NextGen.
And how
Does
about
that help?
It does. When do you, two follow-ups, they're both simple. First, when do you plan to make that down select? And secondly, how about that decision about a Pathfinder versus converting the existing qual unit into a flight model?
Oh, we're going to do the Pathfinder. We're going to do that, period. As I said, it's a Pathfinder plus it puts something on the shelf, and it's for a modest amount of money. Oh, shoot, your second question. Oh, the down select. Yeah. So the RFP should come out shortly in the next couple of weeks to the contractors. And the intent would be to down select in February.
Did you say in February?
I did.
Okay, thanks much.
Thank you.
Okay.
And I've got a question from Ian as well.
Hi, yes. Hi, June. Thanks for the great presentation. Always fascinated with how the RPS development is going on. I had a quick question, and I might have missed this. I know you talked a little bit about the production rate, but you talked about the possibility of having 2 next-gen RTGs ready for missions in the 2030s. Would those be fully fueled in addition to the MMRTGs that are already slated for Dragonfly and a potential Discovery?
Yeah, so we won't fuel anything until a mission comes to pass, right? So, so we don't fuel the systems until about a year and a half prior to the actual launch date. And so right now, how do I explain this? So there's a lot of what ifs that could happen, correct? If Trident doesn't happen, you could fuel 2 next-gen systems for 2030 without any kind of production change. If Trident does happen, we would have to make accommodations. We would likely have to make accommodations to the production rate in order to fuel 2 systems for a 2030 mission. Does that help you?
Yes, that's very helpful. Thank you.
Okay. Yeah, what we try to do is we try to actually every year through PPBE, we kind of look at what is on our horizon, and are we do we have the right production rate in order to support the missions? And we, you know, and it's not like, say that if we had to produce a little bit more, that it costs more money. There is some variation in how many fueled clads DOE can make given the amount of monies that we're providing them. So if we're trying to maybe get another 4 to 8 modules out, we might be able to make that accommodation within our plan. If we needed to get 8+ modules out, we would likely need to have the department gear up in advance, which is why we try to look at it so far ahead of time, because they don't turn on a dime to gear up. And so that's why we try to have this long range vision.
All righty. Thank you for the questions. And I know that our next speaker's got a hard cutoff at 12:30 Eastern. I want to make sure we can keep things going here. June, thank you very much for your presentation. Really great to hear directly from you on all of this.
Thanks for
And
having
I encourage everybody to keep up with them. I know that they have a lot of good information online, and they're doing a great job with their own outreach as a program office. If you find your reactions at the bottom, you can put up a clap for June. Everybody, thanks very much, June. Really appreciate it.